Hi everyone, welcome to Homeschooling SAT Prep channel. Today we are going to start part 3 of average, in which we are going to cover mean, median, mode, range problem. In this video, we are also going to cover some scatter plot problems and box and whisker problems related to mean, median, and mode. If you haven't watched part 1 and 2, I would request you to go watch part 1 and 2 first, clear your basics there, then come to part 3. You can find the link on the top right side. In part 1 and 2, we have already covered average and weighted average problems of low, medium, and high difficulty level. As we have said in first two parts that there will be only 3 parts of average, but we will have one more part in average, in which we will cover in next video, that we will cover margin of error, frequency table problem, standard deviation problem. If you want to seriously prepare for SAT exam, you can check out our various courses on Homeschooling SAT app and website at a very affordable price. All the links are provided in the description below. Now let's move on to the basics now. Before we start the basics of average or arithmetic mean, we should know what is a data set. So what is a data set? It is a group of numbers derived from experiment, survey, and other data collection method. It can be represented in tables, you know, uh, marks obtained by all the students in a class. We can put it on a table, or the age of various members in a family. Then data set can be also represented in pie chart, then histogram, line, bar graph, and few questions at the last I'll take on scatter plot and box and whisker plot also. So now let's come to arithmetic mean. So arithmetic mean and average are the same thing. They are synonym to each other. Whenever we have to find average in statistics or in a data set, it is called as arithmetic mean. Always remember, and both mean and average are synonym to each other, so both of them are the same thing. As we have already read in the part 1 and 2, the average or mean is sum of all the observation divided by total number of observations. So let's say this is our example. These are 5 people, all of them are having different number of bricks. So in part 1, do you remember that Robin Hood approach, where there should be equality among all the people? So to find the arithmetic mean or average, there should be equality. So we need to rearrange these bricks in such a fashion that to make the stack of same height. So as you can see, A has 1, B has 8, C has 3, D has 2, and E has 6. So to have equality, all of them, we should rearrange them so that all of them should have the same number of bricks. So 4, 4, 4, 4, 4. Or we can also use this method, sum of all the observations. So 1 plus 8, 9, 9 plus 3, 12, 12 plus 2, 14, 14 plus 6, 20. So 20, and divided by total number of observations. So 5 people are there. So 5. So 4. So as we can see, to maintain equality, we need 4 bricks for each person. Now there is another concept that we need to learn, that is called median. Median, it is the middle of the data set where numbers are arranged in ascending order. Let's take a data set here. A data set. Always remember, a data set can have odd numbers of data set and a even number of data set. Let me give you some. Let me explain these things with you. Some example. So let's take an odd data set: 2, 3, 8, 6, 1. So we have to find the median, that is the middle. So what is our first step to find the median? First, what we're going to do here is we will put the number in the order from smallest to the largest in ascending order. So first, what we're going to do here: 1, 2, 3, 6, and 8. So this is for this is we have put the data set in ascending order from smaller number to the larger number. Now to find the median, what we're going to do here is we're going to cross out the smallest number and the largest number, and we will repeat the same thing until unless we are left with 1 or 2 in the middle. So first we're going to first this data set was given. Now we have rearranged the data set in ascending order from smallest to the largest number. Now what we're going to do here is we'll cut the smallest number and the largest number. then smallest number and the largest number, and now we are left with only one number in middle, that is 3. So median is going to be the middle number, that is 3. So always remember, when an odd data set is given, then we will get only one number in the middle. But we have an even data set, let's say 3, 1, 2, 4. So if we rearrange them in ascending order, so it is going to 1, 2, 3, 4. So to find the median, what we're going to do here is we will cut the smallest, cross out the smallest and the largest number. And now we are left with two numbers in the middle. So always remember, in odd data set, only one number will be left in the middle, and that will be the median. And even data set, we will have two numbers left in the middle, and median would be average of these two numbers. So 2 plus 3, and their average would be divided by 2. So that is going to 5 divided by 2, 2.5. So median for an odd data set, there will be one number in the middle. And when there is even number of data set, then we will have two numbers in the middle. And the median would be the average of these two numbers. And for odd data set, we will get only one number, and that one number in the middle would be the median. Now, what is a mode now? So as we can see in mode MO, this means most often. So mode is a value in the dataset which is most often found in that dataset, or the most common value that appears most often in a dataset is called mode. Let's take few example. In first example, 2, 1, 3, 2, 3, 3. So as we can see, 2 is coming twice. So 2 is coming 2 times, and 3 is coming 3 times. 3 times. So what is going to be the mode? Mode means most often, or the value appear most. So that is 3, because 3 is appearing 3 times and 2 is appearing 2 times. So the mode would be 3. Now let's take another example here. Let's say 1, 2, 3, 4. So what is going to be the mode? As we can see, 1, 2, 3, 4. None of the number is reappearing. So all the numbers have only one time coming in this data set. So to become a mode, you should have a value that is coming more than one time. Then only it is called as a mode. So here all the values 1, 2, 3, 4, these numbers are coming only one time. So there will be no mode. Now let's take another example. 0, 5, 7, 7, 10, 15, 15, 32. So what is going to be the mode of this data set? As we can see, 7 is coming 2 times and 15 is coming 2 times. So there are two numbers that are repeating 2 times. So both the numbers would be the mod. 7 and 15 will be the mod. If 7 is coming 2 times and 15 is coming 3 times, then what is going to be the mod? Then 15 will be the mod. But if two numbers are coming twice, then both of them would be considered as a mod. And when we have two mods, then this data set is called as bimodal. Bimodal. So now coming to the next topic, that is range. Range, it is a measure of spread in a data set. So the formula of range is equal to the largest value minus the smallest value. So this is the formula of range. So now let's move on to the questions now. The question number 1 says that the table below shows the number of cars sold by John in last year. We have to find what is the mean, median, mod, and range. So first what we're going to do here, first we're going to find mean or average. As we know, mean or average is sum of all observation divided by total number of observation. So as we can see, if we add all the number of cards that were being sold, it will come around 260. 264. So sum would be 264 by total number of observation, that is equal to the total number of months. So total number of months from January to December, so 12 months are there, so it would be divided by 12. So 264 divided by 12, that is going to be 22. This is your mean or average. 22 is your mean and average. Now we have to find median. So we have already found the mean or average. Now we are going to find the median. As we have read in the basics, whenever we are finding a median, first we will rearrange the number in ascending order. Then we will find out the two middle numbers. So we'll start from the lowest number, that is 13. 13. Then we have 15. Then we have 16. Then we have 19. I think we have 19 two times, so we'll take 19 twice. 19. Then which one we have after 19? 22 is there. So 22. Then we will have 25. 125. We have one more 25. 25. Then we have 26. Then we have 27. Then we have 28. And then we have 29. So as we know, the numbers are, because 1 2 3 4 5 6 7 8 9 10 11 12, so we have 12 numbers, that is the total numbers are odd numbers, sorry, even numbers, because we have 12 numbers here, so these are even numbers. So how are we going to find the median of even numbers of the data set? What we're going to do here is we are going to find the two numbers that are in middle. So if this one, this one, this one, this one, this one, this one, so as we can see, we can find these two numbers in the middle. So what is going to be our median? Median is going to be the average of these two numbers in the middle, because the total numbers are even. When we have even, then we'll take only one number divided. We take only one number. Sorry. When we have odd, then we get one number in the middle, and when we have even numbers, then we get two numbers in the middle. So now what is going to be the median? Median is going to be the average of these two numbers. So 22 plus 25 divided by 2. That is going to be 23.5. So this is your median. There's one more way to approach this question of median. Instead of writing them in ascending order, what we can do here is we can cut the smallest and the largest number. So what we're going to do here is 13, that is the smallest number, and the largest number is 29. Then we will cut 15, and the smallest number is 15. After 13, the smallest number is 15. Then after 29, we have we have 28, like this: 13, 29, 15, 28. So we will cut one number from the smaller side and one number from the larger side. Then after this, we can cut 16 and 27, 16 and 27. Then we can cut 19 and 26, 19 and 26. Then we can cut 19 and 25. So 19 and 25 is cut. Now we are left with only these two numbers. These are the middle numbers. So we can find median by finding the average of these two middle numbers. Now moving to the next part of the question, that is we have to find what is the mode. Mode means most often. As we can see here, 19 is coming twice and 25 is coming twice. So what is going to be the mode? Mode is 25 and 19. This is your mode. And now at last we have to find what is range. Range is highest number minus lowest number. So highest number is 29 and the lowest number is 13. So the range would be, the lowest number is 13, yes, 13. So the range would be 16. So this is your range. So your mean or average is 22, your median is 23.5, mode is 25 and 19, and your range is 16. Now let's move on to the next part of next question. Question number 2, it says that the graph above shows the average daily temperature during a particular week in January in a certain city. Which statement best describes the temperature data in the graph above? As we can see, on the y-axis, temperature is given, and on the x-axis, the days of a week are given: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So we have to find what is the mean, median, mode, and which of the statement is true among these four. So first what we're going to do here is we're going to find mean or average. So average is equal to sum of all the observations of 20, 25, 25, 20 plus 25 plus 25 plus, and this is 30, 25, 30 plus 25, this is 20, this is 20, and this one is 35, divided by total number of observations. So we have 7 days. We have recorded temperature of 7 days. So divided by 7. No, let me see. 1, 2, 3, 4, 5, 6, 7. This is divided by 7. That is 155 divided by 7. So 7 into 2, 14, 22, 22 point, and we'll left with 1, 22.1. So your mean average is 22.1. Now we have to find median. So what we have to do, we have to rearrange them. So if we rearrange them in ascending order, then it is 20. Then we have 25 three times. So 25, 25, 25. Then we have 22 times. So we'll put one more 20 here. 20, 25 three times. Then we have 30 and 35. 30 and 35. So total we have 7 numbers. The 7 number that is odd. So we will find the middle one. So middle one is 25. Hence the median is, because 3 numbers are on the left side, 3 numbers are on the right side, and we have one number in the middle. That is going to be a median. So median is 25. Now we have to find the mode. Mode means most often. So as we can see, 25 is most often as it is coming 3 times. So most often is 25. So as we can see that median and mode are equal to each other. The question number 3 says that the list of number 41, 35, 30, x, y, and 15. The median is 25. So median is already given 25. So as we can see that total numbers are 6. So it's an even number. The total number are 6. So it is an even number. So whenever we find, when numbers are in even number, then we take 2 numbers in the middle to find the median. So median would be, these are the 2 middle numbers, 30 plus x divided by 2. In the question, it is already given median is 25. So we'll put 25 is equal to 30 plus x divided by 2. So 2050 minus 30 is equal to x, hence x would be 20. So this number is, x is 20. Now we have to, and after that, the question says that the mode of the list of the number is 15. Mode is 15. Mode is 15. So as we have read in the basics, if a number is mode, it should be appearing at least twice in the data set. So at least one more time we will have 15, because mode means most often. So, and it should appear at least more than once in the data set. So instead of y, we will have 15, because 15 is your mode. 15 is your mode. So at least it should appear twice in the data set. So y is equal to 15. Now what we have to do here is, we have to find, to the nearest whole number, what is the mean. So now we have to find the mean. Mean is sum of all the numbers divided by, we have total 6 numbers, so divided by 6. So 41 plus 35 plus 30, x is 20, 20, y is 15 plus 15. So this is going to be question 156 divided by 6. So that is 2 times, and 36, that would be 36 times 36 equals 36. So this is your answer. So option C, 26 is your correct answer. Now let's move on to the question number 4. The table shows the distribution, sorry, this PF, no, this is going to be of ages of 20 students enrolled in a college, which is correct increasing order. What is the correct increasing order of mean, median, and mode? This question was asked few years back in SAT exam? So this is a very important question. As we can see, we have total 20 number of students, and the frequency says that out of 20, 6 students have. So first 1 to 6 students have their ages 18. Always remember, we have taken frequency questions in statistics chapter. We have covered the concept here. Now for next 5, that means 7 to 12th student, their average is 19. Similarly, after that 12, so 13, 14, 15, 16, so 13 to 16 student, their average is age is 20. So sorry, their age is 20, not averages, their age is 20. So this is how we take the frequency thing. Now let's see how we're going to solve it. Sum of total, as we can see, the sum of total frequency, if we add them up, that would be equal to the 20, that is equal to the number of students. So first what we're going to do here is we're going to find the mod. Mod means most often. As we can see that 6 number of students have 18 age and 5 number of students have 19 age. So 18 age students has highest frequency or the highest number of students, that is 6. So mod age would be how much? Because we have to find the mean median mod of the ages. So mod age would be how much? 18. Because 18 has highest number of students, that is 6 students. So we have already found the mod here. So mod is 18. So it is the smallest number. So mod should be the smallest among these 3. So by this, we can eliminate these 2 options because mod is smallest here and mod is smallest in the option A and D. So we can eliminate the other 2 options because mod is not the smallest, and among these ages, 18 is the smallest age. So by this, we can eliminate these 2 options. Now we will get right option either from A or D. Let's find it out. Now we have to find the median. So median is what? Median, because we have total number 20 students. So we will the median would be 10th plus 11th student divided by 2, because 20 number student, that is an even number. So we will take 2 middle numbers in between. So that would be 10, that would be 10.5th student. As we have seen that first 6 students, 1 to 6, will have an age of 18. Then we have to, because the median student is 10.5, so 10.5 come between in this frequency. That is, after first 6 student, we'll have 7 to 12 student that has an age of 19. So 10.5 will come in this frequency, 7th to 12th. So the corresponding age is what? 19. So median age is, median age is 19. Now we have to find the average as per the now average or mean age is as we can see, we have to find the age of these 6 students. So what we're going to do here is to find the average age 18, and 6 number of students are having this age 18. Similarly, 5 students are having 19 age, 4 students are having 20 age, 2 would be 21, 1 into 22, so 22 plus 23 plus 30, and divided by total number of students, that is 20. So if we add them up, it would be 400 divided by 20. So this is 20. So as we can see, mode is the smallest, that is 18. Median age is greater than the mod age, and mean age is the largest among all three of them, that is 20. So your option A is your mean is the largest, that is 20. So option A is your correct answer. Now let's move on to the next question, question number 5. The diagram above shows a graph of the student test scores in Miss Widow's algebra class with which 10-point interval contains the median. As we can see here, on x-axis, we can see the scores from 41 to 50, 41 to 60, 41 to 70, 41 to 80. And the number of students that have scored in that range, in the score range, is this much. So what we can say that from the graph, I don't know you can see it or not, but 41 to 50 is how much? 2. Because corresponding on the y-axis, it is 2. Similarly, 41 to 60 is 5. but it is, that is 41 to 60. But here, if you have to find 51 to 60, if total is 5 and 41 to 50 is 2, so what this is 5, 41 to 60 is 5, and 41 to 50 is 2. So what we can say that 41 to 60 is equal to 41 to 50 plus 51 to 60. As we can see that this one 41 to 60 is what? 5, and 41 to 50 is 2. So 51 to 61 would be 51 to 60 would be how much? That is going to 5 minus 2. That is 3. So if 41 to 60 is 5, then 51 to 60 would be how much? 5 minus 2, that is going to be 3. 51 to 60 would be. Similarly, 61 to 70 would be, because this 41 to 60 is 5 and this one is 41 to 70. So 61 to 70 would be 10 minus 5, that is going to be 5. Similarly, we'll find for this one, that is 71 to 80. So this is already 10 and this is 18. So this is going to be 8. Always remember, this is given from 41. All the bar graphs you are seeing is 41 to 60, the smallest, to the next 10th place. But here, if we have to find it in interval of 10, because in the answer, the intervals are given in intervals are 10 units apart. So we have to convert this graph into 10 units apart graph. So 51 to 63, 61 to 75, 71 to 80 would be 8 number of students. So now we can solve this, since there are total 30 scores. Since there is total total number of students is 30. So what is going to be its median? Median would be 15 plus 16 divided by 2, that is going to be 15.5. So as we can see that 2, 3, that is 5, 5 plus 10, that is 5 plus 5, that is 10. So till here we have 10. 15.5, here it would be 18, this would be 5, 2. So median is in the range where 15.5 comes. So 15.5 comes in this in this in this bar graph. So that is from 71 to 80. So option B is your correct answer. The question number 6, it says that the table is not above, it should be below. The table below shows the annual salary for 24 members of a professional sports team in terms of millions of dollars. So we have 24 players, professional players, and these are the salaries of those 24 players. If each player's salary is increased by 10%, which of the following statistics does not increase by 10%? So if we increase, this is our data set here, where we have 24 players, and this is salary $0.5 million, and it goes up to $7.2 million. The highest salary is $7.2 million, and we have total 24 players' salary is given here. So the question is asking that if the numbers in the data sets are increased, all the numbers in the data sets, these 24 number data set, if all the values are increased by 10%, so what is going to be the effect on their mean, median, and mode? Are they going to increase by 10% or not? We have to find that out. So instead of taking all the 24 numbers, let's take any 3 numbers, simple numbers. Let's say this is a simple whole number, this is also a simple whole number, and we have 4 here. So let's take these 3 whole numbers from the data set. So 1, 1, 4. So their mean would be how much? 1 plus 1 plus 4 divided by 3. That is going to be 6 divided by 3. That is 2. Now, if we increase the value of these selected 3 numbers by 10%, then it is going to be 1.1, 1.1. And if 4 is increased by 10%, it is going to be $4.4 million. So what is going to be the mean of this after increasing by 10%? We have this data set. So mean is what? 1.1 plus 1.1 plus 4.4 divided by 3. So it is going to be 6.6 divided by 3. So it is going to be 2.2. So as we can see, if we have increased the data set, if you have out of these 24, we have taken only three data, and if we increase them by 10%, and here for these for this 1, 1, and 4, the mean was 2. And if we increase the data set value by 10%, that is 1.1, 1.1, and 4.4, then the mean also get increased by 10%. So 10% increase in 2 is 2.2. So from this, we can say that if the numbers in the data set is increased by 10%, then their mean also get increased by 10%. Now let's find out the mode. Mode means most often. As let's find out the salary which is most often given in this data set. 0.5, 0.5. It is coming twice. Then $1 million and $1 million is coming twice. And let me see, $1.4 million and $1.4 million is coming twice. So the mode would be will be three numbers. That would be 0.5, 1, and 1.4. So if we increase the mode by 10%, then it is going to be what? If we'll increase these numbers by 10%, then the final mode would be also increased by 10%. So mean and mode both increased by 10%. Now we have to find the median. So what is going to be if we increase if we increase these three modes by 10%, then it's going to be 10.55. One would be 1.1 and 1.4. If we increase it by 10%, it's going to be 1.54. So we can say that if we increase the value or the modes by 10%, then the final answer would be also increased by 10%. Now we have to find the median. In median, how many data we have? We have total 24 data here. So what is going to be the median? Median is going to the middle number. That is, in 24, the middle number would be 12th and 13th number. So if we start from 1, 2, 3, 4, 5, 6, this is the 12th number, that is 1.4, and the 13th number is also 1.4. So the average median would be average of the middle number in these total 24 numbers, and the middle numbers are 12th and 13th. So that is 1.4 plus 1.4, and we have to find the average. So median would be 1.4. Now the question says if we increase the value by 10%, that is 1.4 would be increased to 1.5. 10% if we increase it, then it will become 1.54. Then 1.54 divided by 2. So as you can see, there is a 10% increase. So whenever this, as you can see that if the salary is increased, then mean, median, mode, all three of them will increase by 10%. So option D is your correct answer. Always, you can also remember this as the property of mean, median, mode. If the values of a data set is increased by a particular percent, let's say 5%, 10%, 15%, then their mean, median, mode would be also increased by the same 5, 10, or 15% respectively. Now let's move on to the next question. Question number 7 says that there are total 2,400 students at Lincoln School and 3,300 students at Washington School. What is the median number of siblings for all the students surveyed? So as you can see, in Lincoln School, 120 students have no siblings, and in Washington School, 140 students have 0 siblings. And then in Lincoln School, 80 students have 1 sibling, and in Washington School, 110 students have 1 sibling, and so on. So what we're going to do here is, first, we will find the total number of students combined in these schools for number of siblings. So the total would be how much? So as we can see, 120 plus 140, that is going to be 260. Then for this one is going to be 190. This 60 plus 30, 90. Then 30 plus 10 would be 40, and 10 plus 10. So from this we can say that 260 students have 0 siblings. In both the schools, 260 students have 0 siblings. 190 students have 1 sibling. 30 students have. And if we add all of them with all the students both the schools with siblings, the data, then the sum would be how much? 0, 6, 9, 9, 9, 18, 14, 22, 2, and 4, 2. That is going to be 600. So the total number of students that is 600 are having these 600 students are having siblings. The data is given for these 6 students with siblings. So 260 of them have 0 siblings. 190 of these 600 students have 1 sibling. 90 of them have 2 siblings. 40 of them have 3 siblings, and 20 of them have 4 siblings. Now we have to find the median number of siblings. Median number of siblings. So as we know, the total number of students is 600. So what is going to be the median? That is going to be somewhere near 300, 300 and 301 student. So as we can see, first 260 students, 1 to 260 students have 0 siblings. The next 261 to 450th student has 1 sibling, and we have to find the median. Median is 300 and 301 student. That will come in this range. So the median number of siblings would be, because the median of 600 students is 300 and 301, that is 300 and 300.5. That come in this range, because first 1 to 260 students have 0 siblings. Then next 190, that is from 261 student to 450th student, to 60th to 61 student to 450th student have 1, and we have to find, and the median number is 305, 300 and 301 student. That will come in this range. So the corresponding number of siblings is 1. So the median number of siblings would be 1. So option B is your correct answer. Now this is a scatter plot problem. In the scatter plot below, the student A got 30 in test 1. So this is A. So in test 1 he is getting 30, and 70 in test 2. 70 in test 2. As we can see, corresponding to test 2, this is coming at 70. And student B, this student B got 70 marks in test 1, and this is 90, so 90 marks in test 2. So we have to find what is the mean of test 1 and median of test 2 respectively. So as we can see, we can write down the test 1 score. So the test 1 score would be, so it's first 30, then 40, then 52 times. So 30, 40, then these two are 50, 2 times, 50, 50. Then we have 160 and so sorry, 160, 170, 60, 70, and we have 280s, 280s, 28, no, 380s, 380s, and the last one is 100. So we have to find the mean or average of test 1 or mean. So if we add all of these value, you will get 640. And we have total number of how many scores? So total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we get total 10 number of scores, so divided by 10. So average is 64. Now we have to find the median of test 2 scores. So first we'll write the scores in test 2 in ascending order. So this is our test 2. So the smallest one, as you can see, is 52 times, 62 times, 72 times, 81 times, then 92 times, and 101 times. So we will write all of them one by one in ascending order from small to larger value. So 52 times, so 50, 50, then 60, 62 times, 60 and 60. Then we have 72 times, 70 and 70. Then we have 180 and 80. Then we have 290s, the 90, 90, and we got 100. So total number, how many scores are there? 10. So what is going to be the median? Median is going to be because the total scores are 10, that is an even number. So median would be 5th and 6th one. So 1, 2, 3, 4, 5th and 6th are median. So what is going to be the average of these two? 70 plus 70 divided by 2, that is 70. So the average of test 1 score is 64 and the median of test 2 is 70. So option C is your correct answer. Now in question number 9, for 10 meats of different weight, the cost and weight of each are displayed in the scatter plot below. And the line of the best fit for the data shown, which of the following is closest to the average cost per pound? This is very important. Average cost per pound for 10 meats. So what we're gonna do first here? So there are two methods. So first I'll go with the normal method. So what we're gonna do here is first we will write the cost in dollar. Then we will write the weight in pound. Then we will write, because we have to find the average cost per pound. So cost divided cost per pound. So as we can see, in first data set, as you can see, the first pointer, as you can see, it is the pounds are 2 pounds, and correspondingly dollars is 1.5. So $1.5, and the weight of that meat is 2. So 2. So what is going to be the cost per pound? That is going to 1.5 divided by 2. That is equal to 0.75. Similarly, we will do for the next two data, that is 2. So that is, the cost is $2.5. So $2.5, and the corresponding weight is almost 3. 3, so 2.5 divided by 3 is equal to 0.83. Similarly, we will do for this third meat, that is cost is $2.5, and the weight of the meat in pounds is 3.5. So 3.5. So 2.5 divided by 3.5 is, so we can go on for all those 10 meats, and we can found the cost per pound. So what we're gonna do here is we will add all those 10 cost per pound, total cost per pound, and divided by total number of meats, that is 10. So this is one approach, but this is a very lengthy approach. So now we will see a shortcut method. So we have to find what is average cost per pound. So this method was a very lengthy method, because we have to find the cost per pound for all 10 meats, and after finding, then we have to add all of them, and we have to divide them by 10. So this was a very lengthy process. What is the shortcut method? As we can see, that this line that is going, because in the question we have to find the closest approx value. So as we can see, this is a slope here, and we can use the slope formula. So average cost would be slope of line, that is, as we can see, y-axis divided by x-axis. So y-axis, the highest value is 6, and the lowest value is 0, divided by, on x-axis, the cost per pound, because we have to find cost per pound. So the slope, we will take the cost first. So the highest value is 6, the lowest value is $0, and for pounds, the divided by pound, that is, the highest value is 8, and the lowest value is 0. So by using slope of line formula, it will be 6 by 8, so 3 by 4, that is going to be 0.75. And we have to find the approx, that is the closest average cost per pound. So it is almost equal to 0. Nearest value 0.74. So option D is your correct answer. Now coming to the box and whisker plot problem. Very rarely you will get a question from a box and whisker plot problem. I think few years back, 4 or 5 years back, they have asked this question. If you are aiming to score more than 7 or 750 out of 800 maths SAT exam, then you cannot leave any stone unturned. So let's see what the question says. Question number 10, it says that for the box and whisker plot below, so this is your box and whisker plot, and on x-axis we can see the corresponding value is given, and we have to find what are the extremes, range, median, and interquartile range. I may explain you briefly about box and whisker plot here. So as we can see, we have a rectangular box here, and two lines are on the side, on left side. One line is on the left side, and the other line is on the right side. So when on the left side, where the line starts, this point is called as minimum data, and where the line ends is called as the maximum data. Now where the this is our rectangle here, So Q1, where the rectangle start is called, Q1 is called as lower quartile, and Q3 where the rectangle ends is called upper quartile. So this minimum and maximum data are called extreme, and range is maximum data minus minimum data, and the line that is between the in the rectangular box, that is called as Q2 or the median. So median is Q2. That is the vertical line in the rectangular box. So these things are there. And if you have to find the interquartile range, that is Q3 minus Q1. So these are the formula, and this is the basics of box and whisker plot. Now let's find out the things that are asked in the question. The first is extremes. So extremes are maximum data. So maximum data is 39 and the minimum data is 30. So minimum data is equal to 30. Now, second part, we have to find the range. Range is equal to maximum data minus minimum data. So the maximum is 39 and minimum is 30. So 39 minus 30 is 9. In third, we have to find median. Third is median. Median is always equal to the Q2, that is the vertical line in the rectangle. So as we can see, the median is at 35. So median is 35. And now we have to find the interquartile range, IQR. The formula of IQR is Q3 upper quartile minus lower quartile. So Q3 minus Q1. So Q3 is 36 and Q1 is 32. So interquartile range is 4. So these are your answers. These are your answers. So this is the end of part 3 of average chapter. Now these are few practice questions on the topic which I have taught you recently in this video. Do solve these questions to test yourself and write down the answer in the comment section. Students who will answer all the questions correctly, their answers will get pinned in the comment section. Do not forget to watch part 4 of average, where I have taken questions from standard deviation, margin of error. You can find the link of the next part in the description or in the comment section, or you can go to the playlist of this YouTube channel to access all the video. If you like the way I teach and want to buy a comprehensive course for SAT exam starting at a very affordable price, you can check out our homeschooling app and website. All the links are provided in the description below. One more thing, don't forget to like, share, and subscribe to this channel so you can get updates of upcoming free video that I'm going to upload on YouTube in future. Thank you very much, and may God bless you.